channel Done of Chemistry. We are discussing about the thermochemistry. In the thermochemistry, in the previous video, we have discussed how many types of enthalpies are there and what is enthalpy of reaction. In this video, we are going to discuss about the enthalpy of formation. Listen very carefully. This enthalpy of formation is having relation with the stability of the compounds or stability of the elements or stability of a particular substance. Even you see alkenes and alkanes are present and alkynes are present. In organic, we will be having hyperconjugation structure which explains the stability of alkanes. There they will apply this enthalpy of formation concept and they will ask you about the stability. So let us discuss about this enthalpy of formation. This is a very important concept. Nearly 5 to 6 models can be asked based on this enthalpy of formation. How they will ask means, which of the following reaction exactly corresponds to the enthalpy of formation? Calculate the enthalpy of formation for a particular compound by using the following data. Find the enthalpy of reaction by using the enthalpy of formation. What is the enthalpy of formation of for a particular element in its standard state? What is the standard state of a particular element? Find the enthalpy of combustion for a particular reaction. Why for elements enthalpy of formation is taken as 0? That is very important thing. And which compound is highly stable, which will be having highest enthalpy of formation? That kind of questions they will be asking you. First, let us see what is this enthalpy of formation. The amount of heat liberated or absorbed during formation of compound or substance from its elements in their standard states. Basically, this enthalpy of formation, we refer it as standard enthalpy of formation, because we mostly consider it as at room temperature. Mostly we consider it as room temperature. That's why we call them as standard enthalpy of formation. When a substance is formed from its constituent elements in their standard states, amount of heat liberated or gained is called as the enthalpy of formation. Let us see. H2 plus O2 gives 2H2O. The amount of heat liberated during formation of a compound or substance. This is how much compound. Here 2 moles is there, but 1 mole of compound to be formed. So that's why, see, H2 plus O2 gives H2O. Enthalpy of formation. N2 plus O2 gives 2NO. Enthalpy of reaction equals to X. Enthalpy of reaction equals to Y. Half H2 plus half Cl2 gives HCl. Here you see gas, gas, liquid, gas, 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 and then gas. So like this they will give you 3 reactions. So see, amount of heat liberated or absorbed during formation of 1 mole of compound or substance from its constituent elements in their standard states is called as enthalpy of formation. So in any reaction, 1 mole of compound should be formed. Listen carefully, ma. Based on this, in the local entrance text examinations or sometimes in mains also they will ask you. See, this is the thing. You have to consider 1 mole of compound is formed or not. you have to see whether they are present in standard states or not. Standard states. This is what you have to see. See, during formation of H2O, hydrogen standard state is gas, oxygen standard state is gas, water standard state is liquid. So wonderful. Everything is very clear. But you see, 2 moles is formed. During 2 moles formation, X is the heat. For 1 mole, it will become X by 2. So enthalpy of formation value will be X by 2. So X does not correspond to the enthalpy of formation. X by 2 will correspond to the enthalpy of formation. See this one and 2. These are all the standard states, but here 2 moles is formed. So it is not related to the enthalpy of formation. Enthalpy of formation of NO will be Y by 2 will come. But last one you see, standard state, and it is forming 1 mole exactly. 1 mole exactly is there, so Z is there. So enthalpy of formation will be, this one will come. So this bottom reaction exactly explains the enthalpy of reaction. See here, half H2 plus half O2 gives H2O, solid, gas. Enthalpy of reaction equals to P. Will P corresponds to enthalpy of formation? Is it correct, means? Not at all. Why? See, hydrogen is in elemental form, oxygen is in elemental form, but water elemental form or water standard state is liquid. But here we are using the solid. So that's why we will not be considering P as a enthalpy of formation for water. This is a very, very important question. So to understand this question, first you should know the standard forms. You know very well hydrogen, oxygen, nitrogen, for these and all gas form is the standard form, H2O, and then ammonia liquid is the standard form. For HCl it will be gaseous form. If you see carbon, graphite is present, diamond is present, and then fullerenes are there, and then lamp black is present. Among these, what is the standard form for the carbon? If you take phosphorus, white phosphorus is present, black phosphorus is present, and then red phosphorus is present. For sulfur, monoclinic is present, and then rhombic is present, and then plastic is present, and then colloidal is present. What is the standard state for these elements? So whenever the elements are present in their standard states, then only you have to calculate this enthalpy of formation. Among the standard states of carbon, graphite is the standard state. The standard state for this carbon will be graphite is the standard state, and for phosphorus, white phosphorus is the standard state. In this case, rhombic is the standard state. This is very, very important question. What is the standard state of these elements, or what is the elemental form of the carbon? Like that they will ask you. Why? Because for converting graphite into diamond, you have to supply some amount of heat. For converting diamond into fullerenes, you have to supply some amount of heat. And this is the most stable form. Standard state is nothing but the most stable form. So we can explain the stability of a particular element by using this enthalpy of formation. How can we explain stability? Means enthalpy of formation more negative, it is more stable. So for any compound, enthalpy of formation is more negative, means that compound will be more stable. For any element, enthalpy of formation is less, means that compound will be less stable. So see, graphite and diamond, which is more stable compound, means graphite is the more stable compound. You may ask, diamonds are hard, so they should be stable. In nature, which is most available form, that is the most stable form. In phosphorus, white is the most stable form. In sulfur, rhombic is the most stable form. So how to remember these things means, Graphite is the general thing. You can remember directly. Phosphorus. You can remember public works. Public works department or public work you can remember. Sulfur is rhombic, RS. They are side by side. You can remember like this. After some time you get confusion. That's why I am telling you this thing. For carbon, always graphite is the elemental form or standard form. For phosphorus, public works you remember. Phosphorus is white phosphorus, and for sulfur, that is rhombic sulfur. SR you can remember. Like this you can identify the elemental forms. They will give you based on this also some questions they will ask you. Which of the following corresponds to the diamond plus O2 gives CO2 delta HR equals to X. Graphite plus O2 gives CO2 delta HR equals to Y. Is X plus Y? Same they will ask you. Or they will ask you X is more or Y is more. Or in X and Y which corresponds to the enthalpy of formation. This is very important model. Whenever diamond graphite is strongly heated, it get converted into diamond. So enthalpy required for converting one allotropic form into another allotropic form is known as enthalpy of phase transition. Amount of heat required to convert graphite into diamond, that is known as phase transition, and it is endothermic in nature. So that's why always Y will be greater than X will come. Why Y will be greater than X means some amount of heat will be utilized to get cut to convert the graphite into diamond. That's why Y will be greater than X will come. Here more amount of heat will be liberated. Yes, here more amount of heat will be liberated and here less amount of heat will be liberated. This is one of the important thing you have to remember based on the enthalpy of formation. See, whenever there is a chemical reaction, to calculate the enthalpy of reaction, we completely depend on the enthalpy of formation values. It is not possible for us to calculate enthalpy of reaction exactly. That's why arbitrarily enthalpy of formation of elements is considered as 0. Arbitrarily this is fixed. Everywhere, wherever there is element, generally enthalpy of formation is not 0 for the elements. For doing problem or for simplifying the complexity in doing problems, we will fix enthalpy of formation of elements as 0. So be careful with this one. Why enthalpy of formation of elements is fixed as 0 means generally their formation is not 0. If you take oxygen and all means there will be exothermic formations will come. Endothermic formations will be some other elements like NCl3, Ni3 and NF3 will be coming. For some elements enthalpy of formation we fix it as 0. Originally it is not 0. Let us see, this is one kind of question they ask you. Find the enthalpy of formation, or in which case enthalpy of reaction equals to enthalpy of formation. And another case is based on the standard states, they will ask you question. So be careful, this is very important thing. Enthalpy of formation of elements. Let us see the other. Based on this enthalpy of formation, there are two types of compounds are there. Based on enthalpy of formation, two types of compound, that is exothermic compounds, endothermic compounds. Compounds for which enthalpy of formation is negative are known as the exothermic compounds. Compounds for which enthalpy of formation is positive are called as the endothermic compounds. NCl3, NBr3 and Ni3. These are explosive in nature. They are explosive in nature. And exothermic compounds will be O3 will come, CO2 will come and then H2O will be coming. So these compounds are nothing but the exothermic compounds. So during formation of some compounds, heat will be liberated. They are known as the exothermic compounds. Some compounds heat will be absorbed. They are endothermic. So coming to the stability, exothermic are more stable compared to the endothermic. These will be explosive in nature. So these are the basic things regarding the enthalpy of formation. For any compound, enthalpy of formation means amount of heat liberated or gained during formation of 1 mole of compound from its elements in a standard state at the room temperature. That is nothing but standard enthalpy of formation. Mostly standard enthalpy of formation, we will be mentioning it as enthalpy of formation. The next thing is finding enthalpy of reaction. Enthalpy of reaction calculation. This is the problematic part where you will be encountering more problems. Let us consider AA plus BB gives C of C and D of D, enthalpy of reaction. In terms of enthalpy of formation, always remember enthalpy of reaction equals to sigma enthalpy of formation of products minus sigma enthalpy of formation of reactants will come. So enthalpy of reaction is equals to, products are these two. So C into enthalpy of formation of C, D into enthalpy of formation of D, minus A into enthalpy of formation of A plus B into enthalpy of formation of D will come. Let us consider some reactions. N2 plus 3H2 gives 2NH3 will come. SO2 plus O2 gives SO3 will come. CH4 plus CO2 plus 2H2O. 2O2 gives CO2 plus 2H2O. For these reactions, how to find enthalpy of reaction? Enthalpy of reaction equals to 2 into enthalpy of formation of ammonia minus 3 into enthalpy of formation of hydrogen plus enthalpy of formation of nitrogen. We know that for enthalpy of formation of nitrogen equals to 0 and hydrogen equals to 0. Why they are considered as zeros means enthalpy of formation of elements is considered as 0 to overcome the improper values we are getting. It is not possible to find the enthalpy of reaction exactly. That's why the values are not exact values. These are the rough values. Since error is present in every value, that error will be cancelled. So what will be coming? Enthalpy of reaction equals to 2 into enthalpy of formation of ammonia will come. So enthalpy of formation of ammonia will come. What means? Delta HR by 2, as I have told already. For this thing, enthalpy of reaction equals to enthalpy of formation of SO3 minus enthalpy of formation of SO2 will come. The oxygen I didn't mention here, directly I am writing. So see, enthalpy of reaction they give you, one of the enthalpy of formation they will give you and another they will be asking you. And for last one, enthalpy of reaction equals to enthalpy of formation of carbon dioxide plus 2 into enthalpy of formation of water minus enthalpy of formation of methane will come. Like this, we can understand about the enthalpy of formation. Clear? So what is enthalpy of formation? Which kind of problems they can ask you based on this enthalpy of formation, and how to identify the elemental forms of the elements, and how to do problems based on the enthalpy of formation and finding the enthalpy of reaction. This is a very, very important thing. Let me tell you, I told you in organic chemistry they will ask you questions based on this enthalpy of formation. Let us see. The question is, which of the following will be having more negative enthalpy of formation? Which of the following will be having more negative enthalpy of formation? See, these are the compounds we are having. Which of the following will be having more enthalpy, or simply arrange in the increasing order of more negative enthalpy of formation values. So which will be having more negative enthalpy of formation means more stable the compound means more is the negative enthalpy of formation value. So that's why as the molecular weight increases, automatically the enthalpy of formation stability also increases. So A is more stable, so A will be maximum, after that B. Among cis form and transform, which is more stable means transform will be more stable, so that's why that will be having the more enthalpy of formation. Let us see these compounds. A, B, C. Among these, which will be more stable means this is based on hyperconjugation. This is having 3, 3, 6, 7, 8, 9, 10 alpha hydrogens are there, 11 hyperconjugation structures. This is having 6 hyperconjugation structures, and this is having only 2 hyperconjugation. So more is the hyperconjugation structures means more is the stability. So A will be having highest enthalpy of formation negative value. Like this they will be asking you. So be careful with enthalpy of formation. Even in organic also they can ask you problems. So that is the thing regarding the enthalpy of formation. Don't forget to like this video, comment on the comment section whatever any doubt you are having means, and share with your friends. Definitely it will be helpful. Thank you.